Hey students, Mr. Halpern here. This is now the video for percent composition. This is going to be pretty straightforward. There's a formula here that you're not given. As I said in the previous video with moles, you're not given mole-city diagram or the three different conversion factors. You'd have to know that, and it's the same for this one. So percent composition, what this is you're asked, by mass, what is the percentage of each element in a given molecule? So for example, if you want to know the percent composition of, say, NH4, if you want to do that by mass, then you do each element. So if you have this, then first thing is by looking at the periodic table, you write down the molar masses of each. So nitrogen is 14.007, we can say that's 14. And then hydrogen over here is 1. So we're going to go, just write these down, right? And this is 1. Now, it's important to know this and also know that hydrogens, there are 4 of them. So when we're doing the percent of hydrogen, make sure that you multiply by 4. You also want to write down what the total is, because that's going to be what's on the bottom of the fraction for each element. Right, the total is 14 plus 1 times 4 is 4. So 14 plus 4 is 18 grams. Okay, so that's what's going to be on the bottom, 18. We'll start with the first element. For nitrogen, right, N, it's 14 grams of the 18. We're going to multiply that by 100 to make it a percentage. And we'll figure that out. 14 divided by 18 equals 77.8. That's 77.8%. Next, we'll do hydrogen. Hydrogen, as we said, there are each one is 1 gram, but there are 4 of them. So total, there are 4 grams of hydrogen out of 18 again. And then multiply by 100, and it's 22.2. Okay. A good way of checking to make sure that you did it right is by making sure that these percentages of each of the elements in a compound add up to 100%, and they do. And that's really it. Curveballs might be, let's say we go and we do maybe like Al2 NO3 6, something like that, right? You just have to remember, that the Al2 is 2 Als, and that the 6 distributes to each of them, right? So when you're adding up, aluminum in this example, right? This is aluminum, so this would be Al over here, 26.98. We'll write that down. 26.98, right? This is times 2. And then we have 6 nitrogens. We just said that there were 14 grams in each nitrogen, molar mass. And then we have 6 times 3, so 18. And each one of those is 16. So 16 times 18. We're going to set that equal to. So this would be 288. And then there are 6 84. And then 26.98, 53.96. This is equal to 425.96. And again, it's the same exact process, right? I think that's the hardest thing, is just adding up the molar masses. But once you get that, then you take each one. So aluminum's total molar mass was 53.96 divided by 425.96 times 100. Okay, that would be aluminum's. For nitrogen, it would be 84 over 425.96 times 100. And the last one, oxygen, would be 288 over 425.96 times 100. Right? I'm not going to take the time to go just calculate a bunch of stuff. This is how you would set up the problem. You'd plug it into your calculator. You double check to make sure all the percentages are add up to 100%. And that's it. All right.